Good morning, this is your Stat Sensei, Mr. Spensei, and this is an assignment, two sample t-test, and this will be the hypothesis in our scenario is pay up. In a large corporation, an HR department conducts an investigation of whether gender affects salary. Employees who perform the same job with similar experience levels are being used to compare to determine if there's a significant difference in the average salaries. Concerns have been raised about a potential gender pay gap, with many claiming that male employees are compensated more than females. So I'm going to put the claim is males get paid more than females. I use M for males, F for females. The sample consists of 65 male employees. It should say a random sample of 65 male employees and a random sample of 57 employees taken from a population of more than 5,000 males and 4,500 females. The employees are in similar roles and their salaries are collected and compared to assess whether a significant difference in pay exists between the two genders. So there's the male pay of 45,000, the female pay of 42,000. That's the X bars. And we have a standard deviation for each one. Conduct a hypothesis test at alpha equal 0.05 to determine whether there's statistical evidence to support the claim of a gender pay gap, potentially influencing future corporate policies related to salaries. So we have two independent random samples. Because we have two independent random samples, we're going to use a two sample t-test where our equation is x bar 1 minus x bar 2 over s1 squared. That's the, and then s2 squared over n2. All right, so that's our equation. We're going to be centered on the mean. Well, the nice thing about this is we expect to basically mu1 minus mu2 to equal 0. So we'll be centered on 0 on this. And we have males. All we did was input the information from the table. Males getting paid 45,000 with the standard deviation of 5,200. And I'm going to put dollar signs because this is what this is. And we have a sample size of males of 65. We have $42,500 being paid to females with a sample standard deviation of $4,800, and we have a sample size of 57. And we just plugged in. All right. Because we have two samples, this is a two sample t-test for means, and we have mu1 equals mu2. In other words, the null hypothesis is that there's no difference. This could also be written as mu1 minus mu2 equals 0. And that's why we're centered on 0. And by the way, since this is a greater than, I'm going to go ahead and put a greater than symbol there. I'm going to put this here, and we'll come back to it in just a moment. And then this will be the alternative, the alternative of mu1 minus mu2 is greater than 0. All right. So now that we have that, let's talk about our conditions. So we have two, we need to define our parameters. Let mu1 a true population salary for male employees. And then mu2 equals the true population mean salary for female employees. All right. So true population mean for male, true population mean for female. Our conditions. Well, we have two independent random samples, so we have to have independent random samples. Random sample of 65 males, random sample of 57 females. And that's what that was given. And this was also given. All right. Well, 65 times 10 is 650, which is less than our 5,000. And 57 times 10 is 570, which is less than 4,500. So we can say, and we need to say, n is less than 10%. Or you can say n is less than 10% for both. And we are 65 is greater than 30, so it's normal by CLT. Please make sure you're writing normal by CLT. All right, I'm going to highlight that. Let's go ahead and run this test. So to run this test, we're going to go to stat test, drop down to two sample t-test, which is number 4, and x1, well, 45,000. S1, 52,000. Sample size, 65. 42,500 for the female pay, 4,800 for their standard deviation, and we had 57 females. And when we did this, we had a greater than. And we end up getting a T statistic of 2.7604 and a p-value of 0.0033. And we're doing this at an alpha level of 0.05. So 0.033 is less than our alpha of 0.05. So our decision is going to be reject the null. And basically, I'm going to go back up here and label this as 0.0033. Okay. And if I had done my subtraction, we're just going to, for this point, we're just going to leave it just like this. Okay. So our p-value is 0.0033, which is less than our alpha 0.05. All of that, we reject the null. All of that came from right here. P-value 0.033 is less than our alpha 0.05. We reject the null. So this came from that box right there. Then we're going to say there's enough evidence to suggest the true population difference of means. All right, be careful here. When we were doing chi-squared, I mean, not chi-squared, when we were doing paired, it was mean of the difference. Here, it's difference of the means. Why? Because we subtracted the two means. So difference of the mean salary for male employees is more than the salary for female employees. And this right here is also a restatement. Male employees is more than female employees. Male is greater than female employees. All right. Hope that helped. Look forward to seeing you on the next one. Thank you.